In order to understand why economists love the market, let's quickly run over what we did in the previous screencast. So we have 50 consumers, but we only have 10 units of a product. So what we did is we generated an array of utilities for each consumer. Then if we can maximize welfare in this market, what we would do is to sort consumers such that the first consumer in the array is the one with the highest utility, the second consumer the next highest utility, etc. And then we would give the 10 goods to the first 10 people with the highest valuation of the good. Then we can calculate welfare, which is the sum of these utilities, and welfare in this case equals about 127. This will be different in your case because these numbers are random. And then this is the optimization problem that we've actually solved in that case. Now in the market outcome, things work slightly differently. So we first have to define a demand function. So we have a function demand, which is a function of price. So at a certain price P, how many consumers are going to buy the product? Well, that's going to be the consumers who have valuations that exceed P. Yeah, so this part, valuations bigger than P, is actually a Boolean function. I can illustrate that. So we get valuations bigger than 10. Yeah, so that will give me an array of trues and false, whether this condition is true or not. And within Python, these trues and false are represented as zeros and ones. So if I sum them, I get the number of people who have a valuation bigger than P. Yeah, so if I define demand in this way, then we can check at the price of 10 what demand would be, and in that case there would be a demand of 27. So let's get rid of this. So the next step would be to calculate the equilibrium price. That's the price where demand is exactly equal to the supply of 10 units. So how do we calculate that? One way to go is to define a new function which is called excess demand, which is a function of P, and that's going to be equal to demand at the price of P minus the supply that we have, which is 10 units. And now we can solve for the equilibrium price by using from the SciPy library optimize and then the function fsolve. So fsolve looks for the value of P where excess demand is going to be equal to 0. So we have excess demand, and we're going to give it a starting value, let's say 12. And just to check whether everything works out, let's check what price actually is. So we run this, and it finds an equilibrium price actually equal to 12. Now when you look at the notebook, we use something which is slightly more difficult than this, because we have more variables in the demand function, in the excess demand function, than just P. And then when you come to fsolve, fsolve doesn't know over which of these, P and supply, it should actually optimize, in the sense of finding the value that makes sure that excess demand is equal to 0. So now we have to we're going to help fsolve a bit, and we're going to say you should think of excess demand as a function of P only. So we define a lambda function, which is just a shortcut for a function where we don't give it a name. So excess demand depends on P, and supply is going to be equal to 10. And then we run it again, and we see that again we have an equilibrium price equal to 12. Yeah, so just to check that this is indeed the equilibrium price, what we can do is look at demand at price, and that's 10, and indeed we had 10 units to distribute. Yeah, so at the price of 12 we have the equilibrium price in the sense that demand is equal to supply. We can also plot this. So we can define a range of prices using the numpy arrange function. Let's say it goes from 0 to 15 with steps equal to 1. And then we're going to plot range P. And then we want to know what demand is, which is a function of P for P in range P. Oh, sorry, I used the wrong template here. So we don't want to have the simple display, we want to see the picture actually. So here we have on the horizontal axis the price, and then here on the vertical axis we have the quantity. So if the price is low enough, then basically everybody buys. So we have all 50 consumers who want to buy, and as the price increases, we see that demand is falling off. Now, if you're not an economist, you would be happy with this picture, but unfortunately economists are a bit weird in the sense that we want to have quantity on the horizontal axis and not price. So in Python that's easily solved. And if you want to stress the fact that these prices are integers, we can plot it like this. So here we have our demand function at different price levels. So now we can also introduce our supply. So our supply is 10 units, and we want to plot this from 0 to 14. So we get a line that actually gives us the supply, the inelastic supply, and you can see that indeed we have an equilibrium price exactly at 12. So now we can add some more explanation to it. So we can now say that the X label is actually quantity. And what we see on the y-axis is price. And then we have our demand relationship between quantity and price, and we've introduced our inelastic supply of 10 units of this product. So the last thing we need to do now is to see what welfare is in the market. Apologies for that, I pressed the wrong keys. So what is market welfare in this case? Well, again, it is the sum, as we had before, of valuations. But now for valuations that exceed the equilibrium price. Yeah, so again, this is going to be an array of booleans, true and false, and we only look at the case. This part is going to be the array of booleans, true and false. So we're only going to look at the valuations where they are bigger than the price, and then we sum them, and that will give us the market welfare. And now we can compare the two. So we can say print market welfare equals, and we can format this. So let's say we want to have 2 digits. Market welfare. And we know from above that max welfare equals, and again we can format this to F. And this we call welfare. And as you can see, the market actually generates the same welfare as the maximum welfare we would be able to generate. So that's one of the reasons why economists love the market, because the market is actually very efficient in generating an outcome that is the best possible outcome that you can get.